Hello guys, my name is P, and today we're gonna learn vector algebra, one of the most prominent chapters in physics world and my headache too. But today I thought that it might be my first day to start this video. Uh, Before this, I had never tried making YouTube videos to as a career myself. I think it would help me and help you too if you join with me and continue with me for rest of the video. So please watch this if you want to, and if you don't want to, then don't watch. So vector algebra. So we will divide the vector algebra in three categories: basics of vector algebra, direction cosines, and algebra of vectors. These are three categories I will definitely break down vector algebra into. So let me write all these three here. First category is basics and direction cosines. Second is algebra of vectors, and third is collinearity and coplanarity. So I will highlight this all three for you to read properly. Like basics and direction cosines, algebra of vectors, and collinearity and coplanarity. These are my three divisions I will divide vector algebra into, and we will go one by one into each of the three. Let's go. Our first part. I just realized that my notebook doesn't fit in the screen. This is a bit of embarrassment for me, but I'll continue. to basics of vector algebra and direction cosines. Let's go ahead and go for our chapter. Vectors represent one of the most important mathematical systems. So what do you mean by this line? Vectors represent one of the most important mathematical systems. I emphasize on this word, mathematical system. What do we mean by mathematical system? We know about maths. There are various types of mathematical system I can classify, like algebra, geometry, arithmetic, statistic. In that mathematical system, vector is also an important part. That what this line say. Vectors represent one of the most important mathematical system. It means without vector, our maths, it won't be complete. Our physical equations depend on maths, and maths, one of the most important part is vector. So that's why vector is important, and we need to study about vector, because furthermore, if you go in more deep in physics, you will be introduced to kinematics. In that kinematic, one-dimensional motion, second-dimensional motion, third-dimensional motion, in each every case, vectors are definitely used, and they are one of the most used application in whole physics, even mathematics too. So it's one of the most important mathematical system. I emphasize on this line. So vectors can be classified in two categories. One is scalar quantity, another is vector quantity. So we will use our creativity to draw notes. Like I write vector, definitely this crayon sucks. I will definitely edit out this part. They can be classified into two categories. What are those categories? Let's know. First is scalar quantity. And second is vector quantity. Well, I shouldn't say that vector is classified into two quantities. I should have wrote quantities are classified into two categories, scalar and vector. But my fault, guys. Uh, this is wrong here. Actually, we should not classify vector into two categories. It should be physical quantity. My bad, my bad. I apologize. Physical quantities are one scalar and another vector. So what both quantities say? Let's see. So scalar quantities are those quantities which have only magnitude, and vector quantities are those quantities which have magnitude as well as direction with them. It is a bit of complex to understand what I'm saying. Let me write here. Quantities which have only magnitude are scalar quantities. I guess the notebook is out of screen. And what are vector quantities? Quantities which have magnitude as well as direction are called vector quantities. These are our definition for scalar quantity, and this is definition for vector quantity. For example, I will definitely give example. Scalar quantities examples are distance, mass, volume, work, density, temperature, etc. etc. And for vector quantity, I'll go definitely opposite, like displacement, velocity, force, acceleration, momentum, weight. Some of might, if you're wondering what is weight and what is mass. So mass is something which doesn't change, but weight is something that change with respect to gravity. In space, your weight can be zero if there is no gravity, but mass can never be zero. That's a solid difference between weight and mass. So this is most prominent distinguished features between scalar quantity and vector quantity. So, for example, let me tell you, scalar quantity has only magnitude. In physics, there are many physical phenomena. Phenomena which tell only about magnitude are scalar quantity, like distance, 4 kilometer. We just know that it covered 4 kilometer, but where? In north, in south, in east, or in west? Mass, 4 kilogram. We don't know what 4 kilogram. Upward 4 kilogram, downward 4 kilogram. Volume, 5 meter cube. This is a sort of example of volume. We don't know. This is a magnitude. Uh, Understanding what I'm saying? And then there's vector quantity, which means it has direction in them. For example, your weight is 60 kilograms. Your 60 kilogram weight is influenced by the gravity of Earth. That's why your weight is 60 kilogram. The direction is downwards. That's why weight is a vector quantity. And so many examples I can give you. Just be with me. Ahead of chapter there will be many more examples, and it will be very clear for you to distinguish between scalar and vector quantities. But before going that, we can have an exercise. What do you say about that? Let's do that. The question is, classify the following measures as scalars in vectors. Now we will be given some questions. We had to classify whether these things are scalars or vector. First question is 20 meter north west. 20 meter northwest. It means there is magnitude and then see here there is direction. It means the object has covered 20 meter, but where? In northwest. You know, this is northwest direction and it's 20 meter. That's why this is a vector, or you can say it's a vector quantity. It tells displacement. Example of displacement, 20 meter northwest. It means object has traveled 20 meters but in the direction of northwest. That's why it's a vector quantity. We will see more examples of scalars too, like 10 Newton. This is a tricky question. 10 Newton is a vector quantity. Let me tell you how. Newton is the unit of force, remember. And force means mass into acceleration. For instance, there is an object, let's say it is x, and it has mass m. So how do we calculate force acting on that object even though it is in rest? The earth is pulling it to itself, means the earth is pulling that object towards itself. That's why it has some acceleration and it has some mass too. And when we multiply both, we get force. So here, when I say 10 Newton, it means 10 Newton respect to the direction of acceleration. So it's a vector quantity. Clear, Clearly, I'm also not much clear, but I understand that force is clearly vector quantity. Some of the things there are that I had learned uh, as a programmed language, where you don't question too much and it's just written in your memory. Then let's come to the third part. 30 kilometer per hour. 30 kilometer per hour. Tell me, 30 kilometer per hour. What could be this one? So when I say 30 kilometer per hour, but there is no direction, it is the scalar quantity. But if it was written 30 kilometer per hour in the direction of northwest, then it would be vector quantity, and it is what we say velocity. Yeah, this is displacement, this is force, and this is speed. Not actual speed, but speed. Let's head to the fourth question. 50 meter per second towards north. Tell me, it is scalar or vector? It is vector, because same thing that we did to the previous question, there was no direction, thus it was scalar quantity. But here there is a direction, that's why it is a vector quantity. And what quantity is this? This is velocity. And last and final question. 10 to power minus 19 coulomb. If I be honest, I also don't know what is this. But according to net, according to sources, it is also a scalar quantity, because coulomb is the SI unit of electric charge, I think so. And electric charge is considered scalar. We will research more when we furthermore go more deep in physics. Vector is just what you say, the first layer of physics. I would say vectors. You go one level by level, and then when we reach deep depth, we can understand why in the first time when we started the series, coulomb was scalar quantity. Right now, I also don't know why it is. Right now, you may know, but let's say you're not here to tell me. I'll definitely find this one out, why this is scalar quantity. But I definitely know that coulomb is the SI unit of electric charge. So there's a few questions here, very easy, I would say, to clear our definition between scalars and vectors. Then comes the second part of our first part. Our first part was the basics of vector algebra and direction cosine. So we are heading towards the second part, which is called representation of vectors. Means how we will represent vectors. That's a question. Everything is represented by something. For instance, addition. Simple addition, 2 plus 2 equals 4. So how do we represent addition? We had a symbol for it. We have rule how to write what you call the numbers, how we write numbers, the way of writing them, the way of equals to, plus, that, these, those. Everything has a representation to write. So we will study now representation of vectors. So let's go. It's very easy, not very hard. In our previous grades, we definitely had learned about lines, line segment, rays. Vector are represented just like them. Array, you understand, it has a starting point but no ending point. This is how a vector is also represented. This is how we represent a vector. This tells you magnitude, and this tells the direction. This is how a vector is represented. For instance, let's say AB is a vector. A is initial point. What we will say the point A? Initial point. And what will we say about B? It is called terminal point, or even you can say this one, tip or peak. Terminal point or tip. The point A is called initial point and the B part is called terminal point. Let's underline this part. And their representation, see, this one is important. Representation. It is represented as AB, a mark of arrow on there. Done. This is how we represent a vector. There are a few more parts about that, but we will highlight this part, representation of vector. Let's write that diagram again here. This was initial point and this was terminal point. For this whole, we can write this thing as x. We know how to represent a vector, AV vector or even x vector, like this. Very simple, yeah? Very simple. We know vector is composed of two things. One is magnitude and other is direction. Magnitude is definitely AB and direction is AB plus, which gives you vector x, something like this. You definitely heard of modulus function in mathematics. That's something like this. Now there are few points to note. Few points like what few points? Let me tell you what few points. First point, the magnitude of a vector is always a non-negative real number. The magnitude of a vector is always a non-negative real number. What do we mean by non-negative? Either it can be positive, either it can be zero. Magnitude can never be negative. Always remember, scalar can never be negative, and magnitude is part of scalar. So always remember, nothing in scalar can be in negative terms. Okay, only in vector quantities, things like force, displacement can be expressed in negative, but things like distance, speed can never be expressed in negative. Always they are always non-negative, either zero, either positive. Second, there are three characteristics of every vector. Every vector has got three characteristics. What are those characteristics? What do we mean by characteristics? Characteristics mean every vector has these three identities. By recognizing these identities or characteristics, we can say that this one is a vector. Definitely it's a vector. First is length, second is support, and third it's sense. Length, support, sense. It feels like a Dora the Explorer. Length, support, sense. What these three mean? Let's say the length of vector will be denoted by modulus theta 2. For instance, let's say this is our vector. Oh shit, my tripod has struck. I have to hold. Oh shit, oh shit. Yeah, there we go. Suppose this is our vector. So what do we say by length is c. Length we means the measurement. This is vector AB. Length will be represented like this. This is how we write, which equals only AB. Then comes support. The line of unlimited length of which AB is a segment is called the support of vector AB. Maybe this line can be a part of another vector that we don't see, but there is one other vector and it is just a part of that vector. That's what we call support. And last part is sense. The sense of AB is from A to B and that of B to A. Third, the sense of a directed line segment is from its initial point to the terminal point. This one is very important. When I write vector like this, every vector first letter must be its initial one, not terminal one. AB vector is not BA vector. It can never be written as BA vector. If you write this like this is wrong. It is always AB vector, and that's what sense say. Let's move ahead and go for a question. A question. Represent graphically. What do I mean by this? Represent graphically. First is a displacement of 60 km 40 degree east of north. A displacement of 60 kilometers 40 degrees east of north. A displacement of 60 km 40 degree east of north. How will we show this one? We need to prepare our geometry box to represent this one. Not a very hard heavy. We can go just with basic tools like this. A basic graph. This is our base. So we were given to give 60 km 40 degree east of north. East of north means northeast. We protect this is our symbol. Oh no, I forgot the mark. Yeah, there we go again. Let's say this one is AV vector. This is 60 km and it is in east of north. There's another question. A displacement of 50 kilometers southeast. Same phenomenon. We will just go to southeast and keep the protector like this and go for displacement of 50 kilometers southeast, means exact, but just a bit of short because it was 50 kilometers. And let's name this point AC. This is 50 kilometers. And that's how we do our graph. Our question is done. We were given to give a displacement of 60 km 40 degree east of north. This is 40 degrees. A displacement of 50 km southeast. There was no angle given, but it was said southeast, means exact southeast is 45 degrees. As we know, all are 90 perpendicular to each other. So this is our graph. Let's move ahead. Types of vector. Types of vectors. This is a very interesting part. I better suggest you not skip this one. Types of vectors. First one, zero or null vector. Zero zero vector. Let's go ahead what this zero vector means. A vector whose magnitude is zero. Very simple. Zero vector, its magnitude zero. If someone's magnitude is zero, then how it can be represented? Its representation is actually zero. Done. The most simplest of one. Then come unit vector. We will find so many applications of unit vector in motion when we will be given so many dimensions, so many vectors of motion in unit part, and we had to figure out. But today here we are learning basics So it is unit vector. Unit vector. A vector whose modulus means their magnitude is 1 is unity. I wish I say 1 is called a unit vector. Few of the interesting things I want to tell you about unit vector is there's a special type of denotation, or I should say representation for unit vector. Whereas let me say this is a vector A, B, and we definitely write like this thing. How do we represent this one? AB vector to A vector. But in unit vector, if the modulus is 1, we write A cap like this, A cap. Thus, modulus of A cap is always 1. Then we have a formula. A cap equals A by modulus A. It means vector by magnitude gives direction. A very interesting thing which I should tell you. This is very important formula. I want to highlight this one because this is the most important part of the chapter, I would say. This is which unit vector. Then comes like and unlike vectors. like and unlike vectors. Vectors are said to be sorry guys, my tripod fall, so I had to reset everything, but no problem, we will continue studying. Vectors are said to be like when they have the same sense of direction. Simple. Vectors which have same sense of direction are like vector and which don't are unlike vector. For example, A, B is a like vector to C, D, but EF is not like to AB vector or CD vector. That's why it's unlike vector. Very simple, isn't it? Because they have same direction. But F has no same direction, thus it's not like vector, it's unlike vector. Then comes collinear vector. Vectors having same or parallel support. Support means length, are collinear or parallel vector. Let's write this one. Collinear or parallel vector. Let's get ahead. vectors having the same or parallel supports are called collinear vectors. For the same sense of support means this: AB vector is collinear to EF vector. How? This is how what I'm telling about collinear vector. Vectors having the same or parallel supports are called collinear vector. For today, I will left here. So thanks for watching this 1 hour video. I know that there will be no viewer to watch this one, but I tried my best and I'll grow. I'll never give up. Till now, collinear vector. Thank you. Subscribe to.